Hello, and thanks for using TickBoom, a free service that helps high school students with their math problems. In this video, I'm taking a look at part 2 of the two-part question here. So part 2 says to show that cos 4 theta equals 8 times cos squared theta minus cos squared pi on 8 times cos squared theta minus cos squared 3 pi on 8. And this follows on from part 1, which I've just tackled in a separate video. So if you haven't seen that video, I'd recommend you go take a look. That required us to factorize z to the 8 plus 1 into real quadratic factors. And as I mentioned in that video, instinctively, my assumption is that part 2 should really follow on from part 1. Often question writers, when they create these multi-part questions, they're trying to lead you through certain steps to get you somewhere. So I did naturally try and start from my result in part 1 and get to this result in part 2, but I just couldn't work it out. I tried a whole bunch of different ways to manipulate those real quadratic factors, but in no way could I eventually get them into this result here in part 2. So what I'm going to do is I'm going to show this result is true using other techniques. If you're watching these videos and you do have a way to link up part 1 and part 2, I'd encourage you to let me know. That would be great. Please feel free to either comment in the video or get in touch with me through my website. I'd be happy to hear any ideas that are out there. But the approach I'm going to take, I think it's okay, because the question writer hasn't used the word hence, which is what you'll often see when they really do want you to link up the different parts. They'll often say, you know, show something, and then in the next part they'll say hence show something else. But we don't have that here. Sometimes a question writer might use the words hence or otherwise and give you that little escape clause. So they're kind of indicating they want you to link it up, but if you can't, it's okay. If you can find another way, that's cool as well. Here the question writer hasn't said anything, so I'm going to work on the basis that I can use this alternative approach, and you know, it'll still show that the result is true. It just won't do it in the way that I think the question writer wanted. So here for part 2, we're being asked to show that cos of 4 theta is equal to 8 times the cos squared theta minus cos squared pi on 8 times cos squared theta minus cos squared 3 pi on 8. And what I'm going to do, the way I'm going to work through this, is I'm going to take the right hand side and I'm going to show that through expanding it and manipulating it, you get to your left hand side. So the first thing I think we can do is to expand these brackets. So we'll leave the 8 out the front, and we'll get cos to the 4th power of theta minus cos squared theta cos squared 3 pi on 8. And then we'll get minus cos squared pi on 8 times cos squared theta. And then we'll get plus cos squared pi on 8 cos squared 3 pi on 8. And I think from there, what I'll do is I'll just factor out this cos squared theta. So we'll get minus cos squared theta cos squared, I might just write the pi on 8 first, times cos squared 3 pi on 8. Actually, that'll be plus, because squared pi on 8 plus cos squared 3 pi on 8. And then plus cos squared pi on 8 times cos squared 3 pi on 8. So that'll be 8 times cos to the 4th power of theta minus cos squared theta times, and I think at this point we can get our calculator. And if I do cos of 180 divided by 8 squared plus cos of 3 times 180 divided by 8 squared, it's exactly 1. So that just simplifies down to minus cos squared theta. Now if I do cos of 180 divided by 8 squared times cos of 3 times 180 divided by 8 squared. We get 0.125, which is 1 on 8, or 1 divided by 8. Yes, so that's plus 1 on 8. Now, what I'll do is I'll just multiply out the 8, so we'll get 8 cos to the 4th power of theta minus 8 cos squared theta plus 1. So that's how our right-hand side's going now. Now, what I'm going to do is something probably you wouldn't necessarily think to do this, but I think it's going to help us. I'm going to say that plus 1 is essentially the same as plus 2 minus 1. So I'm going to say this is 8 cos to the 4th power of theta minus 8 cos squared theta plus 2 minus 1. So I haven't changed anything, but what I'll do now is I'll factor out a 2. So we get 4 cos to the 4th power of theta minus 4 cos squared theta plus 1, and then minus 1 over at the end. And this, we can see, is a perfect square. This we can actually write as 2 times 2 cos squared theta minus 1, all squared, and then minus 1. Because the first one squared would be 4 cos to the 4th theta, minus twice the product would be minus 4 cos squared theta, plus the last one squared would be plus 1. So that's a perfect square there. And this we can write as 2 times, inside here we can say cos of 2 theta all squared minus 1. And we can say that since one of our double angle rules says that cos of 2 theta is equal to 2 cos squared theta minus 1. So this result here, we've got our 2 cos squared theta minus 1, so we can write that as cos 2 theta. And this, you may notice, is in the same format. 2 of cos something squared minus 1. So we could actually say cos, I'll kind of write out, I mean this is cos 4 theta, and that's because we can say cos of 4 theta is the same as cos of 2 times 2 theta, which is essentially 2 cos squared 2 theta minus 1, applying this same double angle rule. And we had 2 cos squared 2 theta minus 1, so that's cos 4 theta. And that is equal to our left-hand side. Boom! So that's how I've gone about showing that this relationship is true. It's essentially involved a few applications of our double angle rule. And so I haven't linked it up with part 1, but I think it's still a valid approach to take. So hopefully you've been able to follow along with that and it's kind of made sense. If you did find that helpful, please be sure to give the video a like. And if you're someone who wants to keep their finger on the pulse with the kinds of questions that other students are struggling with, be sure to subscribe to my channel so that you can stay in the loop. Alright, tick boom!